last paper for the day. Julia Bauder provides a descriptive title to her paper, Folksomnies, Wikipedia and Semantic Web, using the wisdom of crowds and the power of computing to build a better web. Julia has been the Data Services Librarian at the Greenhill College Library since July 2008. She received her Master's in Library Science degree from Wayne State University in December 2007. Welcome.
So an important ethical challenge is the need to organize information in ways that are appropriate for the world's many diverse groups. Within the North American library community, much has been written, for example, about the need to eliminate racism, sexism, and ethnocentrism in LCSH and DDC, from Sanford Berman's 1971 book, Prejudices and Antipathies, and more recently, Hope Olson's written on the marginalization of feminist topics. This challenge is even more important and even more difficult to solve in an increasingly globalized world. Although physical libraries are often used by diverse populations, the advent of the World Wide Web has created a sort of virtual library accessible to anyone on Earth with an internet connection. Because people from so many more diverse communities have access to this worldwide library, the problem of organizing it in a way that provides equitable subject access for all users is much more difficult. If librarians wish to participate in providing subject access to online information, and if they wish to do so in a way that fulfills their responsibilities under the ALA Code of Ethics to provide usefully organized resources and equitable access, then an organizational system must be developed that does not marginalize any group anywhere in the world. However, as Claire Bechtel has noted, a completely unbiased system would fail in its duty to usefully organized resources. As she wrote in the Journal of Documentation in 2002, and I quote, "Any kind of knowledge representation and/or organization system can be maximally appropriate and useful for the individuals in some culture, only if it is based on the assumptions, values, and predispositions of that same culture." End quote. As Bechtel noted, this makes it very difficult to design a system for global use. Any system that reflects the biases of one culture is necessarily going to be inappropriate for other cultures, and a system that contains, I'm quoting her again, "no representations biased by assumptions about the world, people, society, information, or ethics," end quote, would not be particularly usable by any culture. In this paper, I propose one potential solution to this ethical challenge. As the title of the paper suggests, I propose solutions built on three elements: the user-generated creation of organizational systems such as folksonomies, the collaborative aggregation of community input as exemplified by Wikipedia, and the technologies of the semantic web. Before discussing the ways in which these components could be combined to create this possible solution, I'll first explain some of the background behind these terms and technologies. And I'll begin with the semantic web, which is likely to be the least familiar of the three to people outside of the computer science field. So the semantic web, as proposed by World Wide Web inventor Tim Berners-Lee in a 2001 article in Scientific American, and I'm quoting Berners-Lee here, will bring structure to the meaningful content on web pages, creating an environment where software agents roaming from page to page can readily carry out sophisticated tasks for users, end quote. In this article, Berners-Lee and his co-authors illustrate this proposal with a story about two adult children who are attempting to schedule a series of physical therapy sessions for their elderly mother. Today, the children would have to go about this process step by step. Find a suitable physical therapist who is on their mother's insurance plan. Then contact the physical therapist's office and page through their calendars. Try and find potential appointment times when one of the children is free to drive their mother to the appointment. However, in Berners-Lee's vision, the two children instead use their software agents, which comb the semantic web, find the best physical therapist, compare the therapist's available appointment times with the children's electronic calendars, and automatically schedule the appointments for them. In Berners-Lee's vision, this is made possible by a system for marking up data on the web in a way that makes its semantics, its meaning, machine-readable rather than human-readable. There are currently at least two competing visions of what the semantic web will look like. The first, the one proposed by Berners-Lee, envisions a web where all data will be marked up at a very granular level, allowing for true machine processing of every piece of meaningful information on the page, and where software will be capable of independent problem solving using the semantically labeled data. The second vision, which could be termed the semantic web light, holds that humans will still need to read and interpret much information for themselves, but that semantic web technologies will make it easier to find information on the internet by overcoming some of the known limitations of current web searching, such as the lack of authority control and field and subject searching. Catherine Marshall and Frank Shipman argued in a piece published in the proceedings of the 14th ACM Conference on Hypertext and Hypermedia that there are actually two light visions of the semantic web: the taming the web perspective and the federated data or knowledge-based perspective. In the taming the web vision, the semantic web is seen as a way to catalog the data on the web using a standardized metadata scheme. This would make searching the web more like searching a library catalog, in contrast to the imprecise full-text keyword searches currently employed by most search engines. In the federated data or knowledge-based vision, the semantic web will facilitate cross-database searching by linking together equivalent fields in the many databases that currently exist on the web as separate islands of information. In this paper, when I refer to the semantic web, I will generally be referring to one of the light versions, unless otherwise specified. While the completely machine-processable semantic web has some fascinating implications, its full implementation will require advances in artificial intelligence that are still several years away at best. However, the semantic web light can be accomplished with technologies that already exist or that are in the late stages of development. And I'll discuss these technologies next. So the World Wide Web Consortium has created this layer cake to illustrate the stack of technologies that are needed to build a functional semantic web. I'll briefly explain several of these layers, starting at the bottom of the stack. Uniform Resource Identifiers, or URIs, are used to uniquely identify items on the internet and elsewhere. The most commonly encountered URIs are web addresses, or URLs, Uniform Resource Locators. But URIs can be used to identify many resources beyond just web pages, including images, serials which are uniquely identified by ISSN, and even people. IRIs, Internationalized Resource Identifiers, expands the URI standard to allow these identifiers to be written using characters not found in the basic ASCII set, which includes only the standard English alphabet. The next layer, XML, or Extensible Markup Language, is a widely used language that allows the authors of electronic documents to mark those documents up with tags of their own creation. The tags in XML documents are used to define the structure of the document and to assign meaning to individual pieces of data contained within it. And because of various features of XML that are beyond the scope of this paper, it's very easy for documents written in XML to be shared over the internet without losing the structural and semantic data. And then the next layer, data interchange, is accomplished with RDF, Resource Description Framework, which is at the heart of the semantic web. RDF is an XML-based language that allows users to define the meaning of pieces of information in more detail and with more structure than is generally done when structuring documents with XML. Data in RDF is contained in triples, groups of 3 terms, a subject, a predicate, and an object. For example, RDF could be used to express the idea that Jane Brown, the subject, has an email address, the predicate, janebrown@somedomain.com, which would be the object. And for the most part, each of these terms is defined using a URI, so RDF data can be shared and combined easily. And then RDFS, or RDF schema, allows people and organizations to create their own vocabularies of terms in RDF. For example, terms from the Dublin Core Metadata Initiative have been expressed in RDF using RDF schema. Query is accomplished with Sparkle, the Sparkle protocol and RDF query language, which allows users to search data expressed in RDF and perform some operations on that data. It's similar to the way that structured query language is used to search and manipulate information stored in relational databases. Rules, specifically structured machine processable rules for dealing with specific types of information, allow computers to act logically when working with semantic data. For example, in library systems, one logical rule might be that a specific item can only be checked out to one patron at a time. So logically, if one patron's checked out a book, then another person cannot also check out that same book. RIF, Rule Interchange Format, will eventually allow for such rules to be shared between systems. RIF is still being developed, so at this point it's difficult to say precisely how it will function. The ontology layer. Ontology is a word with multiple definitions in the information science community. While many people use the words ontology and taxonomy interchangeably, in this paper I'm using a definition of an ontology from Ellen K. Jacobs' 2003 article titled Ontologies in the Semantic Web. And I quote, "In the environment of the semantic web, an ontology is a partial conceptualization of a given knowledge domain shared by a community of users that has been defined in formal, machine-processable language for the explicit purpose of sharing semantic information across automated systems." End quote. In other words, ontologies, like traditional taxonomies and classification schemes, are intended to organize some field of knowledge into related and typically hierarchical categories. But they differ in that ontologies are written in a computer language and are interpreted and applied by machines, while taxonomies and classification schemes are written in human language and are interpreted and applied by people. In practice, this often means that ontologies require a higher level of explicitness in their categorizations. Human users can read scope notes and draw on their personal knowledge of the world to determine how broader, narrower, and related terms fit together. But computers must be told explicitly if, for example, the narrower term is an instance of the broader term or a component part of the broader term. OWL, or Web Ontology Language, is the language in which ontologies are generally written for the semantic web. OWL expands on RDF and includes a number of terms that can be used to describe the relationships between various concepts and classes. Terms such as same as, intersection of, union of, and subclass of. In the interest of time, I'm going to skip talking about the upper layers of the layer cake. These layers are necessary for Berners-Lee's vision of the full semantic web, but the light version of the semantic web, what I'm discussing today, can function without them. Many people, including some librarians, have seen the semantic web as a technological solution to the problems of applying traditional subject cataloging methods to information on the open web. However, attempting to impose a universal set of subject headings on the web would not only port the ethical issues of traditional methods into a new environment, but it would also be unlikely to work. Although the semantic web provides the technological infrastructure necessary to apply traditional subject cataloging on the web, it does not provide the human infrastructure, people who are both willing and able to apply the metadata properly, and users who know how to search metadata effectively. Historically, using taxonomies to organize information has required very expensive professionals to manage the taxonomies and to assign the subject terms, which makes it financially infeasible to catalog the entire web in this fashion. It takes constant vigilance by teams of librarians and subject experts to ensure that ontologies stay up to date, and learning the rules for assigning the correct terms is a complex process that requires much training to learn. While it is possible to ensure that library catalogers receive at least some level of training, it's not feasible to force such training upon everyday internet users, who, because of those financial limitations, will have to be the ones assigning subject terms to their own or others' information on the web. To quote Karen Schneider, the user is not broken, and librarians are unlikely to succeed in convincing internet users that those users must be trained to organize their own information collections. Indeed, the rapid growth of the phenomenon known as tagging suggests that many internet users already believe that they can productively organize the information that they use. Many sites, including Flickr, Amazon, and LibraryThing, now allow users to add tags, words that describe items such as photographs and books, to items on the site. These tags, which are essentially metadata, can have a variety of functions for the people who create them. Some users deploy tags to organize their collections for their own purposes. These users may or may not particularly care if their tags are useful or even intelligible to other users of the site. Others tag their items in the hope that the tags will make searchers more likely to find their items. and still others tag socially in order to join a community of people who demonstrate their interest in a particular subject through tagging. In some ways, tagging and folksonomies, the folk taxonomies created by tagging, are ethically preferable to centrally controlled subject headings, since they allow for individual self-determination in the organization of one's information world. However, most tagging systems have practical problems that make them unsuitable for large-scale information organization. A quick analysis I did of some Flickr tags demonstrates one of the issues with using tags as an organizational system. So I attempted to find all the photographs on Flickr that had been tagged as being related to Penn State University, and the results of that search can be seen here. Two tentative conclusions can be drawn from these results. First, a positive one. Many of the people who post photographs on Flickr are clearly concerned with the problem of synonyms and are willing to tag their images with more than one form of a term to ensure that it will be found. Over half the people who posted photographs tagged with Penn State, the most popular tag, also went to the trouble to tag the image with PSU, and nearly half of the people who posted photographs tagged with Penn and State also tagged the photograph with PSU. Second, despite the effort that Flickr users appear to be willing to expend, there are still two major non-overlapping pools of Penn State photographs. Of the 9,953 photographs tagged Penn State, and the 2,791 photographs tagged Penn and State, only 319 are tagged with both. This experiment dealt with a relatively concrete and well-bounded concept. Although Flickr users may disagree on the proper term for tagging photographs of Penn State, they probably do by and large agree on what is and is not Penn State University. Consider, on the other hand, how difficult it would be to attempt to use tags to find all the photographs on Flickr that were blue. Should a turquoise photograph be labeled blue, or would the user have labeled it turquoise? Where do users think the boundary is between blue and turquoise? Or if the users think that turquoise isn't a legitimate color and turquoise photographs are really blue, where's the boundary between blue and green? And the question gets even more complicated when other languages are brought into the picture. Some languages combine blue and green and sometimes additional English colors into a single color. Russian separates the English concept of blue into two distinct colors, light and dark blue, and other languages place the boundaries of their equivalent of blue differently. If individual users were allowed to decide on their own whether a given photograph should be tagged as turquoise, blue, green, or some other term appropriate to their language, as is the case now, it's nearly impossible to use the tags alone to find all of the images that have been tagged as being a different color. So if tags are to form the basis for any widely applicable knowledge organization system, then some way must be found to aggregate the data from a diverse and disorderly collection of user-generated terms into a structured ontology that indicates how the tags relate to each other. Ideally, this aggregation process will involve many users from a given culture working together to reach a consensus about how they want their information world to be organized. The best example of a successful consensus-based online information project is Wikipedia, the online encyclopedia where anyone can add or edit content. Wikipedia is not part of the semantic web. Its articles are structured for human readers, not for computers. But the community-driven success of Wikipedia and the processes that brought about that success shed some light on how the folksonomy model can be adapted to make it a usable basis for a semantically marked up web. Despite widespread skepticism, Wikipedia actually has become a useful source of information. A much-cited study in the journal Nature tested 42 pairs of articles on the same scientific topics from both Wikipedia and Encyclopedia Britannica. The articles were sent in pairs to scientists who were experts on the topics, who were asked to review the articles for quality. It was a blind review. The scientists were not told which article came from which source. And the scientists evaluated both the Wikipedia and the Encyclopedia Britannica articles as being of roughly equal quality. An equal number of serious errors, 4, were found in the articles from each encyclopedia, and the number of minor errors was roughly equivalent, 3 in the average Encyclopedia Britannica article and 4 in the average Wikipedia article. Further work suggests that the quality of Wikipedia articles may have improved somewhat since that time. A study by Dennis M. Wilkinson and Bernardo A. Huberman in First Monday found, and I quote, A strong correlation between number of edits, number of distinct editors, and article quality in Wikipedia, end quote, suggesting that the longer that Wikipedia exists and the more people contribute to its articles, the better it will get. Basiki, Stabilia, and co-authors, in a study titled Information Quality Work Organization in Wikipedia, also found that the more attention an article receives, the more its quality improves. Featured articles, the approximately 0.05% of articles that the Wikipedia community has selected as outstanding and worthy of a featured place on Wikipedia's front page, had discussion pages that were, at the median, 10 times longer than the discussion pages for a randomly selected set of articles. So each article on Wikipedia has an associated discussion page where users can debate the quality of the article, potential changes to the article, and the like. So in order to build ontologies that are likely to meet the needs of culturally diverse searchers and that will attract buy-in from culturally diverse internet users, some sort of Wikipedia-like method must be developed to allow all users of the ontologies the opportunity to bring their own perspectives to the task of creating them and to facilitate the creation of a consensus on how the ontologies should be structured. So let's consider a relatively straightforward example of how this might work. Returning to the problem discussed above about various tags that indicate color. Imagine that we have a group of photographs that people have tagged with different terms in many different languages for shades of blue. And imagine that some users want to indicate how all of these tags fit together. They want to create an ontology, although they might not think of it using that term, so that they can bring together all the blue photographs. An English-speaking user might begin the ontology by saying that turquoise is a subclass of blue. And then more English-speaking users might add that navy blue, cornflower blue, and so on are also subclasses of blue. And a bilingual Spanish-English user might add a relationship indicating that azul is the same as blue. And another Spanish-speaking user might add relationships indicating that the various Spanish words for shades of blue are subclasses of azul. And as the relationships were added, people might debate some of them. Should turquoise really be a subclass of blue, a subclass of green? Are two words in different languages really equivalent or not? And as more users contributed to the ontology, and as the relationships were discussed and modified, eventually a relatively complete and agreed upon mapping of the domain of colors would be created. Obviously this is somewhat simplified, but as in Wikipedia, it works more often than not. This example imagines a single ontology. But if a group did not agree with the organization of one ontology, the members of that group could easily use the same process to create their own that indicated a different set of relationship among the tags, or that was based on different tags entirely. So in conclusions, semantic taxonomies would combine the benefits of traditional subject cataloging, bringing like things together effectively, the ability to deal with the problem of synonyms, and the ability to indicate the relationships between different topics, with a more culturally welcoming and hence more ethical method for developing ontologies and assigning to information the subject terms that a given community of searchers will want to use to find it. For semantic taxonomies to be useful, a group of users simply has to agree on the relationships between some tags, and some of those users have to use semantic web tools to create an ontology that indicates those relationships. Individual users are still free to tag information in whatever ways are useful or meaningful to themselves and/or their communities, as long as some users take the time to lay out the relationships between the tags in the instances where those relationships reveal useful information or allow productive searches to be done on the data. This is a messy approach, but it combines both the benefits of the semantic web, being able to structure information in a way that allows the computer to process it, which allows online information to be more usefully organized, and the ethical benefits of tagging and taxonomies, namely letting people arrange their information worlds in the ways that are most appropriate for themselves. Thank you.
Questions for Julia?
You mentioned about Wikipedia that the more an article is accessed or used, the better it gets. Isn't that kind of the same thing as the mainstream gets the attention and then there's a marginalization of the minor themes again? Or do you think there's a way to reconcile that or to make up for that lack of attention
The attention doesn't have to come from the mainstream. I mean, there's still likely a fairly small number of people it takes to make a good Wikipedia article. If you have a marginalized community that has, enough people who are willing to participate, it can still function. It'll still work. And there is the problem with Wikipedia of the mainstream drowning out the minority, but there's always the possibility of going and creating your own. I mean, there are other wikis besides Wikipedia. And that's one of the things I was saying, that a community that feels like they're not being well served by one semantic web ontology can go create their own. It's a fairly low overhead process, so it is still very possible, very easy for them to do so.
And just to add on that, how does one become the article, the featured article?
There's a voting process, and you nominate it. I'm not exactly sure how it works.
But it does end up being majority rules again.
Yes, but yes, it does.
As a heavy user and contributor of Flickr, I would agree with I think what you were getting as a limitation of tagging in large sets. I suggest you get a different example though, because using words to retrieve images by color, it's just folly. Most people aren't going to tag that way, and tools exist now. Some of them small scale, but rapidly improving, especially for Flickr, for retrieving color images by color, because by any sort of best definition of objective we can have, those are the objective means, and that they're looking at the underlying data of, say, a JPEG image or whatever, which is an objective standard, and they're using that. And you can point at a specific spot on the photo, or you can, some of them you can choose a specific photo, and say, go off of this, and find everything that has these colors in it. And that's really the only sort of natural way to do it, and certainly the only way that you can swipe and be objective. So while there's still sort of small scale, that problem is solved.
But people do tag photographs of Flickr by color, and that is a way that people will use.
But especially when you bring in, when you want to retrieve all of them. I mean, people talk about Flickr and retrieve. It's not a database, so it's not like you can use this keyword to retrieve every image that has. You can retrieve possibly every image that has that keyword, of course. But there may be 40,000 times more images that actually have that same content that are that. In fact, most people don't tag their images ever. So they're going to semantic talk. We talk about retrieving all the images, or that's
all the ones that have assigned that tag is what you've got to work with most of the time.
Are you familiar with DBpedia?
I've heard of it, yes.
Oh, okay. How does it relate to what you proposed here?
That DBpedia, if you're not familiar, is actually an attempt to make a Wikipedia-like thing that is semantically marked up. I think it's great. I think it's wonderful.
Can you spell that?
DBpedia. Yes.
.org.
Yeah, I think it's great. I'm not exactly sure what tools they're using to do that, but that's an excellent example of the kind of thing I'm talking about. This paper's a couple years old. Freebase was the one they were trying when I actually originally wrote it. I did have a section in, but I took it out as soon as they fell apart.
Okay, thank you very much. I think I can speak for everyone when I say that this has been a fascinating day. We invite you to continue the conversations with the speakers and yourselves at the reception at the Doubletree at 5:30. Just to remind you, Michael's message this morning to take a peek at the rotunda of the library. You need to go out, take a right, take another right, and the entrance to the library is on Wisconsin Avenue. Close at 5:30.
5:30.
Okay. Anything else?
Tony was going to give just a few more details regarding the reception and the logistics.
Hi everybody, I just want to let you know, if you signed up for the reception, we had that denoted on our spreadsheet, and the reception is complimentary and it includes 2 drink tickets. Now if you look in your name tag, if your name was on the list, checked as yes, that you were going to be attending the reception. Your tickets are already in there. You have them. They're good. They're good at the bar area. What's going to happen is we're going to have a separate room just adjacent or across the hall from the bar. And so to get a beverage, you just go ahead and walk across the hall. They're good. I forgot to type on it that they're also good for soda and water and non-alcoholic beverages. You can see where my priorities were this week, the week after finals was over, obviously. So yeah, they're good for that, and then they're up to call brands of any cocktails or anything else. So if you have any questions or anything, feel free to see me. Feel free to grab some food on your way out. It's just going to go anyway. There'll be light hors d'oeuvres at the reception, and thank you very much.
And we're going to head down there. We might be able to get it started